grade systems across different technologies, across different cloud providers like AWS, GCP, Azure. And currently, I work at the intersection of DevOps, AI, and real-world infrastructure failures. And I also help DevOps folks to move from theory to battle-tested executions into DevOps. And this session is going to be about the practical insights, the real incidents, and how to think like a production engineer, and how to troubleshoot the outages that we face on daily basis as an DevOps or as an SRE or as a platform engineer. So yeah, so I'll first start with this agenda of how exactly we are going to move with the call, what are the different things that is involved in the call and all. So as you know that this call is going to be a live outage troubleshooting, and all those people that we have on call with us, I can see almost 15 to 16 people that we have on call. We are going to troubleshoot all together, and we are going to divide all the folks into different squads, and each squad is going to troubleshoot the outage on their own. Okay, so we're just gonna swipe the slide. So yeah, here is the another thing that in this session we are not just going to learn about the theoretical concepts. We are actually going to get our hands dirty on the real infrastructure failures that we see on daily basis in our organizations and on our infrastructures. Okay, so what all you are going to experience in this session live. So we are going to start it with the very basic of what exactly is an outage, how to understand the technicalities of an outage, what are the different kinds of outages, and how to understand and try to create out a mental model for you troubleshooting. That's the most important part, to actually understand how to troubleshoot. And then after understanding how to troubleshoot, we are going to jump on how to identify the different patterns in an outage, and then we are also going to talk about the timeline forensics. That is very important if you are solving out an outage live in your organization. Every second that you are trying to solve out an outage, it is going to cost a lot to that organization. So in an outage scenario, each and every second is going to cost you and your organization a lot. So just to understand that part, we are going to cover out the timeline forensics and everything. And then apart from that, as I mentioned, that in this call we have close to 14 to 15 people. So we are going to divide all those folks into two different squads, squad alpha and squad beta. And those squad will be having an incident commander who will be responsible for taking out the decisions that has been suggested by the team members, and every other engineers will be helping them troubleshoot by trying to think in different direction. And there will be two different squads, and we are going to divide, I guess, 7 people in each squad. Okay, and then at last we are going to talk about RCA. That is the most important part. If you are someone who is working as an SRE, so you know the pain of creating out a root cause analysis documentation, and why it is important. We are going to talk about that, and how to create that. We are also going to talk about that stuff. So, and yeah, so we believe at Infrathrone that if you are actually looking to master out this outages, this production outages, if you are really someone who is trying to understand how all this works, so the best thing is to analyze the different patterns in which the outages happen. So if you are someone who is very interested into this outages domain, and has observed this AWS outage that has happened in the last year, because of that the US East 1 was down 2 to 3 times in the last year. So it's about understanding the pattern that has caused the infrastructure go down. So it's about mastering that all pattern. So we'll also try to do that, and since it is somewhere close to 1.5 hours session, so it will be not enough time for us to explore all this, but I will be also sharing down the documentation which will help you to understand all these patterns and all. Okay, so now the goal of this session is going to be that we are not just going to guess that what it can be. Like in if you have observed like observed these things in the real outages scenario, if you are someone who has been into war rooms, so we often see that people are guessing the random stuffs in the war room. Like it can be a networking issue, it can be a data layer issue, it can be the compute layer issue. So we will eliminate that guessing part, and then we are going to jump on a structured debugging, a structured troubleshooting. We are going to learn that, and then we are going to implement it live on a problem statement that we have replicated in the LMS itself. Okay, and here is the most important thing, that in production, speed matters, but clarity of what exactly you are executing on your own system, that is the most important part. Now, having said that, I'll be just moving to the first part of the session, that is about understanding how and what are different outages. So here is the another slide. It will take another like 10 minutes to explain this concept, and this is quite important for you to understand before we jump in the real arena and try to sort out an outage. It's very understand the problem statement and all. So yeah, let's get started with this. So um, uh, I see that we have close to 17 to 80 people in the call, and some of the folks are pretty new to this domain of DevOps and SRE platform and all, and they don't have any idea, or they have an idea but have a wrong idea of what exactly is an outage. So if you'll ask them that what exactly is an outage, so they will say that the application has crashed. They will say that my pod is down, my pod is crashing, image is not able to do that. But this is not exactly an outage scenario. If you have misconfigured the system, this is not outage. So outage is something that you have two different systems, two different components of your infrastructure, which is not able to communicate directly, and that is causing the communication go down. And here are the different examples that you can see, that I have two different services, the checkout service and the payment service, and they are not able to call each other. So that we will consider this as an outage. And similarly, if I do have a microservice deployed in Kate, and that is not able to go into downstream and pick out the data from DB, so that we call as an outage. And if my pod is not able to talk to the application API, so this we call as an outage. So application outage and infrastructure outage, there are two kind of outages. So we as an DevOps SRE are responsible for infrastructure outages, and it is important for us to understand how to troubleshoot this kind of outages in our infrastructure. Okay, so being said that, if you are aware about the blast radius of an outage, that is very important to understand what kind of outage category you have. So there are three kind of blast radius with us. One, actually, if that outage is exterior to that organization and the customers are getting impacted, then this kind of outages are considered as an P1 outage, as a kind of a red alert that the customers are impacting, or either the reputation of that organization is on hold and you are responsible to sort this kind of outages. And then we do have the second kind of outages that hamper the internal productivity of your engineering team. So let's suppose you do have some development stuff going on in your dev environment or set environment, and let's suppose that is down. So it is going to cause the degrade in the productivity of your internal engineering team. So that should be also considered as an outage with a lower blast radius, as in the P2 or P3, depending on which all environment it is happening. Okay. Now, here is the most important part, to how to define the problem statement. So if you are working as a DevOps, it is very important that if you are defining the problem statement correctly or not. So it is it is actually a skill if you are into DevOps, and if you are able to define the problem statement in the right way. So as you can see that what exactly is the wrong way, that my service is down, application is not working. This is not the way we define the problem statement. The correct way to define the problem statement is my this system is not able to reach to the this system, and in this system I do have a microservice which is deployed in the K, which is not able to communicate to the other system, which is into different namespace or other things like blah blah. So here is the correct way to define the problem statement is who cannot reach what. So the who will be the first system and what will be the second system. Okay, now here is again the most and the second most important part is to if you are troubleshooting a live production outage, so like it will be actually a negative point if you are not reproducing the problem statement from the right place. If you are reproducing and trying it out in a different environment, then that can hamper your troubleshooting strength. So let's suppose if I have production outage and I am trying and testing it in my laptop, in my work laptop. So that has a different configuration. My laptop has different packages installed, different operating system, different architecture. It may be the 86, it may be the 64-bit, and the server that is deployed in the production that is having the different configuration, the system architecture, and all those things. So uh, uh, it is important that you are reproducing it at the right place from it is supposed to be. Now, here is the next step that you have to do in order to troubleshooting is to check one step at a time. Now, I see people that they often jump the layers and they try to see what all is going on without verifying the previous thing. And that is the worst way to solve an outage. And the ideal way is to go step by step, layer by layer of what all is going on. So as you can see that I have started it from the networking layer, that is my DNS is working or not. And then I have get into that infrastructure and trying to step down into different things. And then is my service is existing, endpoints existing, pod reachable, app responding. This is the correct way. Now, this flow is called data flow. How exactly the data is flowing inside your infrastructure in and out. So to divide that part, we have upstream flow of data, midstream flow of data, and downstream flow of data. Now you have to categorize the outage in these three streams. So if your outage is in the upstream, that means it is mostly towards the networking, and it is mostly towards the traffic that is trying to reach to the infrastructure, but somehow it is getting delayed, or it is just not able to reach out to the downstream data. So if you categorize the data into these three streams, the upstream flow of data, the downstream flow of data, the midstream flow of data, you'll be able to decrease the blast radius, and you'll be able to understand it in a lot more clear way. And as you can see that I have tried to create out a data flow of how exactly the data is moving from the traffic, from the client that is generating the traffic and requesting requesting a response from the server, and how the response is getting um, um, successfully delivered back to the client. That is the complete part of how exactly the data is traveling. Now, if you are clear about this whole path of how exactly data is moving in your infrastructure, then you will be able to identify that one component that is causing issue in your infrastructure, that is causing ultimate downtime or any production outage. So the most important thing is to understand how data is flowing and categorize into upstream, midstream, and downstream flow, and to create out a data flow path of what all is integrated and how to move forward. Cool. So now I see that most of the people, if you are into a war room, if you are into a DevOps war room, most of the people start with logs, and that's the worst way to get started. So logs are not something that will tell you exactly what has happened with the system. Logs are the symptoms that exactly has caused because of some another chain reaction. So let's suppose if I have a communication issue reaching from service A to service B. So logs will tell the health status or how exactly the service B is behaving until and unless if you have integrated tracing in your observability, that is another concept. But since we are talking only about logs, so if you're starting with logs, that is the worst way to start with, because it will exactly tell you the symptom of what a chain reaction has caused. It will not exactly tell you what exactly has happened in your infrastructure. It will tell you what exactly the chain reaction has caused. So here, in order to identify how it happened, you need to start with the data flow thing, not with the logs. Logs will be helpful in the later stages if you are troubleshooting and trying to get the idea of the component status of or how this component is interacting with other things. But logs will not tell you this part, that how exactly this happened. So this thing you need to figure out, and the best way to figure out is to identify the data flow in your infrastructure, how exactly the data is flowing in and out of your infrastructure. Now, moving to the next thing, again, if you are into war rooms, so often most of the DevOps engineers say this kind of things, that it can be service layer issue, it can be application issue, it can be this, and they don't check that. So first thing, if you are into a war room, make sure to check everything without making any assumptions. So if you are making any assumptions, make sure to check it. Just verify what you think. Do not assume anything that this can be that, this can be that. Oh, I have made this configuration, so that's why it is reacting like that. Make sure to check the configuration before you are just assuming other things in your head. And that's the most important thing. Now, here we have tried to categorize the failure, and since it is like a kind of beginner session into production outages, so just to have a beginner friendly view of what all categories that we have in the infrastructure failures, we have categorized into 4 different domains. The first one is the service is not able to find another service, and that can be a DNS issue. And then the service is not able to reach out to another service. That can be a network service endpoint issue. And then the service is not getting scheduled on server. That can be all this issue. And it may be the application is broken. It can be the code or the config issue, right? So we have tried to simplify this thing from a beginner's point of view, that what all can happen in your infrastructure, and if this all is happening, what to do. If you want a better guide on what can happen in your infrastructure, and then if you are trying to have this thing in your mind, that if that happens, then what can be the issue. So for that, I guess I have written out a blog here. I'll show you. I just pasted out this link in the chat, and you can just get into that after the session. So this is specifically to Kubernetes. So if you want to know that if this component has broken, then what all can be the issue in my infrastructure. So as you can see on the screen, that if there's an API server issue, then what all you have to do and all this kind of stuff. I'll be just sharing down this link in the chat, with not going into detail. Is this I can see a chat saying the voice is echoing. So is this for everyone? If I can get a thumbs up, if it's for, like, if it is good. Uh, okay, thanks. Okay. So here is the next thing of what not to do. So so as we have seen throughout the slides, that we don't have to start with logs. We don't have to assume anything without verifying of what all can happen. So do not start with logs. It will be useful in the middle of troubleshooting. You don't have to start with logs. That's the first thing. You don't have to restart blindly. I see most of the people that without knowing the issue, they are restarting the machine like IT team. So you don't have to do that. You don't have to guess anything. You don't have to jump layers. Try to follow the OSI model. OSI model says that you have to execute things in order. So networking layer, and then the application layer, the data layer, all those kind of things. Go one by one, layer by layer, in order to troubleshoot if you are not getting any idea of what can be the root cause. So what you have to do, define the problem statement clearly of who cannot reach what. That is a framework that you have to set in your mind of who cannot reach what. Reproduce it from the right place, not from the wrong place. Make sure to have the right configurations. Trace it well from a flow path point of view. So try to define the data flow in your mind, how exactly data is traveling, upstream flow, midstream flow, downstream flow, and then verify each of the things that you think can be the root cause. And if you are at a back end, try to follow the OSI model. That's how we debug at production. Okay, I have already explained out the core rules on how to debug: define, reproduce, trace, verify. Okay, now let's jump into our problem statement. So before jumping into the problem statement, Sanket has actually shared a link in the chat, and this is the link. So try to hit this link, log in first, and then we'll be able to create out the teams for you, and we'll be able to assign teams to you. So Sanket, are you? We have close to 27 people on the call, so I guess we have to create 3 different teams. So try to have 8 or 9 people in a single squad, alpha, beta, and gamma. Okay, and try to assign people, and then we can get started with that.
Yeah.
Meanwhile, till now, I'll just give you a walkthrough on how exactly the platform works before deep diving into the problem statement. This is pretty interesting for you to first understand before you deep dive. Okay. Okay. So you'll be able to see your squad here. It will say the squad name and all those kind of stuff here itself. And then in the lab section, if you'll go, you'll be able to see a lab with the name of system degradation under recovery pressure. That is our problem statement for today. And if you'll just click on view details, it will show you the problem statement. As you can see, I'll explain the problem statement. I will give you a terminal walkthrough of what is the problem statement and the context of the infrastructure. So just and walk through on how exactly the platform works. So as you can see, an overview, a problem statement, the current situation in our infrastructure, the overall objective on which you have to fight, and then there are some constraints that kind of a limitation that you don't have to do this, and then here is an expected outcome of what is the expected outcome from this lab, and then we have some investigation node that you can follow, and a final line of what is the outage. Just click on the start lab and you'll be able to redirect to a terminal, and this is the terminal where exactly an infrastructure will spin up for you. This infrastructure at the backend, we are creating out an infrastructure and we are injecting a failure and we are breaking the system up, and then you are supposed to fix that system back to the healthy condition. Here in the right, you can see the problem that involves each and everything that I have told you earlier. And then here are some hints. So for each of the team who will be solving out this production outage, you'll be getting points out of it. So if you are revealing the hints out there, it is going to cost you. Okay, so if you are into a black end position where you don't know what it can be, so make sure to just reveal out the hints. If you really don't know of what is the problem statement or what can be the solution of it. And then here is AI troubleshooting enabled for you. So this has all the context of what all resources we have in this terminal. Just enable this button up and it is going to read your terminal. Make sure to ask the right question because in as of now, in today's time, if you have different AI agents like for troubleshooting, GPT, and tons of AI agents, right? So we believe that if you are using that in a right direction, if you are asking the right question, it is going to benefit you. So that's why we have enabled this stuff. AI troubleshooting for you, and this is going to help you in your troubleshooting journey. And you will be having 30 minutes of time to debug this problem out. And in 30 minutes, you are supposed to debug this. And after debugging this, if you will click on submit, it is going to validate your solution statement of if you have really applied the right solution or not. If you haven't applied the right solution, it is going to deny the submission, and you'll be redirected back to the same screen until and unless. And the second case is the problem statement, the solution that you are applying. What kind of solution that you are applying? Let me phrase that. So what optimized kind of solution that you are applying is like, is it space or time complexity? We are also observing that part. And once you submit this thing out, there will be a screen of RCA generation. So RCA is the most important part, and creating an RCA is a true art. Okay, so after completing out this incident, after 30 minutes of troubleshooting, you will be redirected to this screen. And here, if you click on begin, then it will ask you what exactly happened, and you have to explain. Let me just put down this. Copy out some sketches out there. Okay, so I'll explain you meanwhile it is loading up. I guess I don't know why. Okay, I'll just copy out few of the text from here just for the demonstrators. So here you have to, okay, so here you have to explain what exactly happened. And then if you will get into the next page, it will ask you about when did it occur. So in an RC, that is the most important part, to explain all those fields. And after this session specifically, we are going to share you two professional RCAs, a bad example of how to create out an RCA, and a great example of how to create out an RCA. So we have created out this template to show you a great example of that. So that way it will ask you for all those details, and I guess it will ask you for 10 to 15 fields, which will cover out the technical root cause, how you have fixed that, explain that, and then at last how you have make sure that this will not happen again in your infrastructure. So this all fields you have to make sure that you are filling this up, and then after submitting this RCA, you will be able to see a screen where overall points on how exactly you did, and the report card on what you did, how you did, and what exactly you missed, that will occur on your screen. And then we'll be redirected to the same call to discuss about the solution statement. Okay, so that's the flow. And meanwhile, again, so this is the screen, by the way. And this thing will take around 4 to 5 minutes to spin up, and this is excluding of those 30 minutes that you will get for troubleshooting. Okay, cool. So I guess we are all sorted. Sanket, have you noted down all the email IDs and created out the squads?
Not everyone is not joined yet. The LMS.
Okay, so guys, I request everyone to just click on this link and get into that page, and then only you will be able to add you in a squad for this live troubleshooting. Otherwise, you will be excluded of that, and that's the real game to actually experience that. Sounds good. Okay. So let's now move to the problem statement. So this lab is just spinning up in the site. And till then, let's try to understand the problem statement. Okay, so here is the problem statement. I'll be first explaining out visually on what is the problem statement. And then we will actually go through a walkthrough of those infrastructure components that is involved through the terminal in order to understand that. And then we are going to split all the people into squads on this call, a breakout room, and a live troubleshooting in the next 30 minutes. Okay, I know we are extending a bit. Okay, no worries. Okay. So here is the problem statement, and this will be also available to you after the session, after the live troubleshooting starts. Okay. So here's the problem statement. The title of this outage is the system that won't calm down. So it has all started quietly. So no alarms, no red dashboards in your Grafana. Everything was looking great. Just a low priority message in your Slack or Teams channel that, hey, anyone else seeing slightly slower responses from the backend server that we have? And somebody thought that it can be the internet issue from that side. I like it's for me, it is working absolutely fine. So that's the moment where it all started. Okay, so it is a kind of a storytelling of how exactly it started. Okay, then here is the timeline forensics of what exactly I've talked about. So in each of the minute of outage, what exactly happened, I'm going to explain all those details. Okay, so it started at 9:11 a.m. IST. Okay, and at 9:11, it says that there was some latency increases, not enough to alert and push out an alarm to the engineers, but not enough to accelerate this to the main channel. So it was looking all okay for those kind of people who are pretty much experienced into the infrastructure. They would think that it can be an issue. So pods were running, nodes were stable, deployments, no recent risky changes has resorted to the production. Everything was looking normal. At 9:15, we have received few more messages in the Slack channel. So they were like that some of the requests are now taking longer time, getting occasional timeouts. Still, it is not consistent throughout the whole infrastructure. For some of the people, it is timing out, and for some of the people, it is taking longer to respond. And if you are someone who is already experienced into war rooms, then you know it will make you uncomfortable that something is going wrong in my infrastructure, right? So as a DevOps, we have landed on the real infrastructure to test it out, and you as an DevOps have started this. So the first call succeed, the second call slow, the third call times out. No clear pattern. You should the traffic. There wasn't any spike in the external traffic. All was looking good. No external traffic, nothing, no unusual pattern that we are getting. And that is not something that is unusual. It is pretty okay in the infrastructure that there is no external traffic. Everything is looking good from external point of view. But still something is going on in our infrastructure. Now, just to check all this, that what all is going, what all we have done. Another DevOps engineer have tried to check out from a CPU point of view. CPU was looking fine. Memory was looking fine. Nothing was maxing out on the server side from a resources point of view. Everything was looking fine, right? So why the behavior of this infrastructure is degrading like that, as some of the peoples are able to get the response, and for some request it is timing out, and for some request it is working. This is a kind of a mixed feeling from an infrastructure point of view, right? Now at 9:27, the logs start filling up, not with errors, with repetition of retry, retry, retry. That was all that we can see on the screen. Okay. At 9:29, you check the game. No external traffic. Everything was usual. The system was serving the normal traffic that we serve on weekdays, weekends, every day. So there wasn't any increase on the external traffic that we are getting. Still, our system feels like something is degrading. Okay. Now, suddenly, what happened at 9:31? That latency had spiked up, and what was occasionally failing at this moment of time for some of the requests. Now it is a kind of a pattern that some more people are actually telling that my requests are failing, and all of those clients suddenly telling my requests are failing. So it feels like under the load, but still from an infrastructure system point of view, it looks all clear. But it feels like the system is not breathing properly, right? And that's the problem. Okay. So now from 9:33 to 9:37, what all is happening? So even more slower responses, and then the slower responses get into more failures. Then those failures are doing internal activity and causing even more slower responsive. Now, this is what is happening, and it's a kind of a loop that we are in. Now, it's clear as of now that nothing externally is driving our infrastructure mad, right? So here is the thing, how to stabilize this infrastructure. Let's try to understand that. And now everyone has no idea, like as of now we have. So as of now, we are thinking that something is failing, right? But we don't know what exactly is failing. And here in this case, our system components are looking healthy, like the pods, the services, the endpoints, everything is looking healthy, but still the system is accelerating its own failure. We don't know why. And I guess for some of the people, it has already clicked. If you know, you know. Okay. Now, what exactly is your mission? I guess there's a mic. If you guys can, yes, there's a mic. Okay, thanks. Okay, now what exactly is your mission? So the mission is that you guys are brought into the situation as DevOps experts. Now, there isn't any pods that are failing. There isn't any infrastructure alerts. There isn't any obvious misconfiguration in your system. Nothing as in clear error messages. But still, latency is rising, failures are increasing, and internal activity is growing, which is hitting your system down. That's the problem statement that we have. Now, there are some rules of engagement that you have to follow. You don't have to assume the first symptom that you see that this is the first symptom. It is the root issue, because it is a kind of a chain reaction that we have created. Okay. So if you are assuming the first symptom as the root cause, you are already dead in that moment. You don't have to chase logs. Why? I have already explained that. You don't have to restart blindly. Again, I have explained that. And you don't have to assume external pressure, since I have already mentioned there are no external pressure. Now, follow the behavior and try to understand what all is going in the system. Okay. Now, you will be having 30 minutes of time. So you will be dividing into squads. You have already, I guess, selected for the squads, and you'll be able to see also the same in your screen of DevOps Spark. And then you have to identify the bug, debug it quickly with the help of AI troubleshooting hints and with your team, obviously. And then you have to verify the fixes, create out the RCA, and then we are going to talk about the solution statement. And if the troubleshooting and all is going to take a bit longer time, we have already created out the run books and everything that I'll be uploading on the LMS, and you guys can verify your solution, understand those all areas that how exactly this happened. Everything we have already explained in that video. So the most important part is get involved in this troubleshooting. If you are into squad, try to help your squad to troubleshoot this faster than other squads, and those who wins, they are going to get uh, a month of access of LMS, and we'll be able to explore all the problem statement that we have. So we have more than 100 plus outages that we have simulated in our DevOps Park. And it has three different layers. It has three different tracks: the core ops tracks, the battle ops tracks, the elite ops tracks. The core ops tracks is for those people who want to build their foundation in outages, explore the core ops tracks. Battle ops track is for those people who have a bit of experience to DevOps and now struggling with outages. And this is the battle ops problem statement. The third problem statement and the track that we have is the elite ops. So elite ops are those kind of outages that has happened in the past, like the AWS outage that I have explained to you, the Cloudflare outage, the CrowdStrike outage that has happened last year, the Netflix outage. We have simulated it all. So if you are someone who thinks they have a lot more experience in expertise, go explore elite outages out there, and it will give you uh, a fun experience solving all the outages in this arena. Okay, so we have explained out the problem statement. Now here is this lab. I'll just give you a walkthrough on what all is going on from infrastructure component point of view, and then you'll be able to just kickstart. Okay, just Sanket, are we able to start this top mid session? Just to confirm this part. Is it
What?
top mid issue has been fixed over?
I guess yes.
Good. Okay, so are we live, right?
Yes.
Good. Good. Okay. So now this is the infrastructure that we have. This is the namespace. So for different squad, it will be different namespace. So here for me, the namespace name is lab and blah blah blah. Okay. Now let's first copy this namespace and try to see what all is going on. Let me increase the font. Okay. I hope it is visible to everyone, right? Okay, can I get a thumbs up if you are able to see the fonts? Cool, thanks. Okay, so this actually shows us everything running inside the namespace. We are not analyzing the issue as of now, okay? We are just identifying the different components that we have in our infrastructure. As you can see, we have pods, we have services, we have deployments. Now let's try to get that pods and try to check the configuration and all. So I'll be just cleaning out the screen. kubectl get pods in the namespace that we have. Okay, so this all namespace that these all pods that we have, and let's try to. Okay, so as you can see, the pods are in a healthy condition. They are running, and the IP has been assigned. It is live on a node, so all pods are already scheduled at node, and they are at running in a healthy condition, right? So now we have multiple pods. Each one represent a running workload in the system. So at high level, if I have to explain you, these workloads have different responsibilities. Okay, these are the two workloads that we have: the traffic worker and the API gateway. Now they have different responsibility. One workload is acting as a service provider, and one workload is acting generating the activity. So for traffic worker, it is generating the activity, and then API gateways serving the traffic provider. Okay, now that's the two components that we have. Let's try to also check the services in the same namespace. So I'll just get SVC. Okay, so this two are the services that we have, and this services act as an internal access point. Other components inside the cluster that we have actually communicates through that. Okay, then now let's try to describe one of those services to understand what all is going on. So we'll do kubectl describe SPC, and let's describe API service. Just use it by namespace. Okay, so this is the service that we have. Okay, and this actually tells us how the traffic is routed here. So which pod receive request from when this service is called. Okay, so you can check the selector, you can check the endpoints. All is looking good, right? So now let's try to get the endpoints. I'll show you the endpoints now. And by the way, if you want to decrease the fonts and make it small, you can do via that. Okay, I guess for the questions, make sure to just paste down in the chat. I'll be explaining out the this part, that how you'll be talking to your team in your squad, and we are going to jump on that. Just stick with this part first. Okay, now check the. Let's try to check the endpoints. That is kubectl get endpoints, and just using the namespace. Oops. Okay, so these are the two different namespaces that we have, and these are the actual pods behind the service. So when somebody calls the service, traffic actually lands here. Okay, now I'll be just describing one of those pods out. Okay, so let's try to describe API gateway in order to understand. So I'll be just copying out this pod ID, kubectl describe pod in this namespace. Okay, so this is the pods, and this workload is responsible for serving the responses, and we just observe how it is configured here. So here you can also observe the container image, the limits and the request, the ports, the readiness, the QoS, and everything has been mentioned here. Also the events you can explore here itself. And then if you want to just also explore this one, describe this one, I'll be also showing you this part. See, these are the infrastructure component that we have. We are just describing our two different pods that we have, two different workloads that we have. Now let's try to understand the flow that we were talking about, right? Who reach what, right? That's the most important part. So just zooming it out a bit. And to actually do that, let's try to, so in our case, I'll be just writing out here. So in our case, what exactly is happening? So we have a traffic what? Worker. Traffic worker is responsible for generating the activity inside the system, okay, and it is interacting with the service that I've shown you, and this service is forwarding the request to the another workload that we are having, that is responsible for generating back the response to the traffic that it is generating. So here in our case, the flow would be from traffic worker, it is getting into API service, that is the service, and from service it is getting into API gateway pods. Okay, so this is the clear flow that we have in our head, right? So now we have an idea of what exactly is going on. So this is a basic request flow inside the whole system, and one component initiates the request, another handles the request, and there's a service in between to connect each of this. Okay, now also let's try to do one thing. I'll just doing a basic connectivity test to show you. So here we are just confirming that communication is even possible between these components or not. So for that part, we're just executing this simple step. I'm just executing into, okay, so I guess, hold on, just check pods. Okay, so we are getting into traffic worker, and let's try to call. Here is traffic worker, and then you can call the, let's call to check. Okay, so if you see, we are just confirming if the communication is possible between these components or not, and all is in the screen if you are able to understand. It's good. Also check what all we can see. We can check the logs, right? Let's check the logs that I was talking about. So let's do log, and then let's check out the namespace. So there are some restrictions in the lab that you cannot create alias of the namespace or any other alias, and there are another restrictions also that you cannot play with the nodes and all. So you'll be only able to access this all infrastructure that I am talking about. Okay, so here we are now checking down the logs of the traffic worker. Let's check out the logs of the traffic worker. Let's try to tail the last 20. Okay, these are the logs. So logs give us visibility into the workload is doing something, right? And we are going to use this at the later of this investigation. Do not start with this log. I've shown you for a purpose, so do not start just with the logs. Okay. Now this is, I guess, we have covered all this thing. We have covered the workloads, we have covered the services, we have covered the connectivity test, we have seen the logs, everything. I have shown you from an infrastructure point of view. Now you are understanding what is the problem statement. And now we understand the system at a very high level. And there is a service request, receiving the request, and there are pods behind the service processing them. And there is another workloads generating the traffic request flow internally within the cluster through this part that I've already told you. And this is a problem statement that is happening. Now let's start the game. You are having 30 minutes of time, and you are responsible to debug in a squad. Every member is responsible to help each other, and for those team who will be solving this at the first time, at the earliest time, they'll be getting the access of LMS for the 1 month. Okay. And okay, so I guess we have already started, right? So Sanket, if we can create out the breakout rooms right here.
The rooms are created. Also, those who joined the LMS are given the access.
I missed it. What? Sorry. If you can come again.
The rooms are created,
Okay.
and those who joined the cohort, I have given them the access.
Great, great, great. So let's check the room. If you can also give me the host permission, so I'll be able to see that. Yeah, Harish is having some doubts. Please go ahead. You have raised out your hand. Harish, you there? Harish. Okay, so I can see that no one has joined all the breakout rooms yet. So have you announced the squads? Sanket?
Yes, the spots are made.
Okay, so guys, just try to join your on squads. I can see that people are joining the squads. You can see in Alpha, Sumit has joined, and in Gamma, Ronnie has joined. So make sure to join your own squads. We're just waiting you guys to enter the war room. And best of luck. You don't have to ask for links. If you will, I'll show you. I'll show you a quick demo on how to join out the breakout rooms. Just, I believe you guys are able to see my screen. So if you'll just click into this button of meeting tools, you just have to scroll down into breakout rooms, and you'll be able to see the option to join your specific room. Go there, and you'll be able to see that. Hey, Sudhanshu, I see your message that you're not able to see that option for your chat window. If you can
Yeah,
share your, if you can share your screen, I'll just help you out with that quickly.
yes, yes.
Sure. Guys, do not stay in main call. If you are, I see a lot of people is still in the main call. Join the breakout room and leave this call.
Yeah.
We are going to execute the things there itself. Yeah, Sudhanshu. Please
Can
go
you see? I mean, I can see only these things.
ahead. No, 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 no. Hold a minute. Let me check.
Click the three dots.
Yeah,
The first bottom right extreme. Yeah, yeah, that's
This one,
extreme right. Extreme right.
uh,
these.
exactly the meeting tools. Yeah.
Yeah.
Just scroll it down. The breakout rooms.
Scroll down. Breakout.
Yeah. This one.
Unavailable. I mean, these are due to meeting restrictions.
Sanket, if you can back here. Yeah. Check on that. Guys, if you are still in this main room, try to join out your squad room, and we'll be starting.
Try to rejoin the meeting.
Sorry.
Rejoin the meeting.
Okay, okay.
Still, we have a lot of folks in the main room, right? Yes, yes. No worries. Hey,
If anyone wants some help, let us know.
Arav, Ashwin, Kushal, Mohammed, Raish, Raj, Rakesh, Siv, if you guys are having any doubts, please ask it. You're still in the main call. We have started out the call. Guys, are you able to hear me?
Yes, we can hear you.
Yes, we are
So
in calls.
yeah. So if you can join the breakout rooms, you'll be able to see the.
There is some group assignment mistake.
Just a quick question. In the lab session, I'm in the squad called Gamma, but in this breakout room, this breakout room is called Squad Alpha. So I was wondering, should I be in the breakout room for Squad Gamma because my lab session is called Gamma? Okay, could you? Okay, add me there, please.
Yeah, me too. So I need to be in squad beta.
Okay, it's okay if I leave the call, if I leave this and okay, thank you. I've seen it.
Lab.
Not yet.
It still shows fetching lab files for me.
It's the same for everyone.
Okay.
Sure. Yeah, is it expected that it's been like 7 minutes and the lab is not yet provisioned? Yeah, I think it's in the file. Okay, okay. I can see configuring access now. Okay.
I'm sharing my screen.
Like at least checked in the lab for some logs or that flow, etc.
We are yet to determine. I think it's whoever's lab provisions the first. Maybe you can share your screen. Oh, okay. So we need to delegate it to one person, right? Let me share my screen then.
Sorry, can you please? Okay, but okay. Can you see my screen?
Yeah, hi. So yeah, we are trying to type something here, but nothing works. Yeah, nothing works. Good.
Guys, everything is sorted here. Just to check.
No, Saurav, we are unable to type anything into the terminal.
You have to take out the control. I guess the control is with Rajendra in your team.
No, no, I think it's with Shravan, and we all tried. Rajendra, myself, and Shravan, we all tried, but
Okay.
we are not able to type it.
Just once again, let me just check this.
Shravan, are you able to type anything now?
Nothing. Let me refresh and try.
Can you try to click on the terminal and see, or try to copy paste something? If anything works, I don't know. Nothing. Okay. I think it's not working. Yeah.
Yeah.
Are you here, Sanket? Just to confirm. Yeah. Sort this. I'll be jumping into another squad to check.
Rajendra, you mean?
Yes, I can hear you.
No, did you mean Rajendra or Rajesh? I mean, I just see Rajendra. Yeah.
Okay, give me a second.
Please share your screen. I will do-
Same issue. Wait.
I think it will take another 9 or 10 minutes. Okay. So
So I need to leave.
So we all should leave. I think back to Shravan then. Shravan, can you please share your screen and leave?
So you just want me to end it?
Which one shall we look? Look at the traffic worker. I think that would look, that looks maybe the thing. Yeah. So minus F logs minus F. Yeah. Correct.
Yeah.
Retry timeout, retry timeout, retry timeout और कुछ नहीं मिल रहा. Okay. That's the only logs we are getting. So let's look at pods again. Let's look at debug. Yeah.
Yes, go ahead.
It is not giving any error.
So here, okay, let's do one thing. kubectl, okay. Get pods minus O wide. Let's look at the IP addresses of the machine. Okay, so this one gives me 192.168, 135, and 79. Okay.
There are two nodes are there.
Sumit, your mic is not, it's interrupting. ऐसा लग रहा है कि आपका कोई गला दबा रहा है करके.
Okay. Now I hope
Now it is better. Now it is better. हाँ. बोलिए क्या करूं?
Okay, now let's check the node connectivity. If node connectivity is a problem.
Node connectivity can't be because kubectl get nodes. I'm forbidden, so I don't have the access. Right?
We can't go to the
yeah.
node
So
connectivity.
let's do one thing. kubectl minus n. यहाँ नहीं चलेगा. यार ये कॉपी पेस्ट करने नहीं देता है. Minus n get deployment. Okay. So there are two deployments. Okay. Yeah.
Number?
Okay, sorry, I forgot. I was trying to say I was muted. You had to pass the pod name. You forgot the pod.
Don't use get pods. Instead, use exec.
Yeah.
And like you get
Exec.
pods, you can exec pod
name.
lab debug. Use the lab debug. We are trying to reach the API gateway from the lab debug. So just
Yeah.
okay, that would work out as well.
So which one? A backend service it is trying to reach, right?
That won't make you're already on that pod, so you can't use its own IP. So probably use another IP, like let's say traffic worker, but
Directly use the endpoint. Scroll up and pass the endpoint name.
the SVC endpoint. You can use the SVC instead of the IP because
Directly above you already have.
Where?
Scroll up.
No,
Yeah, here.
this one.
sorry.
Yeah, endpoints.
Okay. So you're asking me to for this one, right?
Yeah, you can try both. It's okay.
Exact. Sorry, lab debug, right? So this is able to.
हम लोग कोड को तो चेंज नहीं कर सकते अभी,
Let's
कोड
let's describe the pod to check the whether there is any inconsistencies.
डिस्क्राइब. अच्छा, क्यों डिस्क्राइब करने से क्या होगा? क्योंकि एप्लीकेशन कभी कभी तो ठीक
yes,
चल रहा है, से कुछ नहीं, कोई पीवीसी नहीं है, कुछ नहीं है, तो डिस्क्राइब करके क्या मिलेगा?
yes, yes. एग्जैक्टली डिस्क्राइब से तो कुछ नहीं मिलेगा.
लॉग से तो लग रहा है कि एपीआई गेटवे, हाँ कभी कभी बीच में इंटरमीडिएट
कभी कभी स्लो आ रहा है.
हाँ, तो मिशन स्टेटमेंट वापस क्या है? रिक्वेस्ट वॉल्यूम फॉर क्लाइंट रिक्वेस्ट begins timeout intermediately, overall latency increases, the requests do not consistently complete from backend perspective are received and processed or normal system-wide behavior. Okay, identify constraint, do not modify backend service logic or response. Do not rely on scaling as the primary solution. Focus on interaction between components, avoid fixes. Expected reliable. Okay, increase ingestion. Okay, let's do one thing. kubectl -n get pods. नहीं, ये कॉपी नहीं. अरे यार क्या टर्मिनल है यार, सर टैब मारने से नहीं आता है, गधे लोग.
we have copy symbol as well.
हाँ, get pods. ठीक है, get pods.
From lab, I'm trying to reach to the API, although I'm getting something as okay. Maybe we can start checking for logs now.
Just a quick question. Did you try? Okay, sorry. I think I'm confused.
Now you are getting exception occurred during processing of the request.
Otherwise, it was socket server.py broken pipe error. And this was for API gateway logs actually. Now, if I check for lab debug.
Okay, can you do a kubectl get pods in kube system namespace?
Yeah, just.
I think we are good on that pod.
Yeah.
Looks good.
Do you have any restarts?
No.
I think we are good. We have no restart, so the system pods are okay. I think we can look at. I think that log error you found here looks interesting. Server.py looks like there's an intermittent failure. When a request is received, there's an error. Exception occurred during processing of request from. Where is this IP coming from? Can you
see? Is this request failed due to timeouts?
Error number broken pipe. One request.
So this is somewhere a request is coming from. Exception occurred during processing of request from this, and 45188. Looks like this IP and a port.
Look, it seems according to me, application is correct. It is the part of the API pod or DNS server. Okay, so can you check for the logs of the DNS? So that application is keep on running, but you can see after some time it also gets
kubectl. Probably it needs, yeah, now we can do kget PO.
Parts or service?
Yeah, let's see what are there on the same namespace. Lab debug or traffic worker. So API gateway. Does anybody remember like what Saurabh was explaining, how the traffic comes? Or
Yeah, from the traffic gateway to the API gateway service.
And
to the API gateway pod.
Just to check the describe, like which one is the failing. kubectl describe pod name.
Okay. The lab debug is actually a deployment, I think. Okay, it's just a pod. Okay. Successfully pulled image, API gateway started. Okay. Successfully assigned. Okay. Waiting. So there's no problem here. Let's see next. I mean, everything is in running state.
only some requests are failing. You know, maybe some pods in deployments are not healthy.
Okay. -n logs -f worker. Yeah.
Yes.
Retry timeout. Okay. ऐसा करते हैं, वापस एडिट करके उसको रिट्राई करते, क्योंकि इसका प्रॉब्लम नहीं है ये. ठीक है, इसको रिस्टोर कर देते हैं. ठीक है, ठीक है. Okay, let's try to edit get deployments. Edit deployment जो दूसरा वाला है ट्रैफिक वर्कर, उसको एडिट करके देखते हैं. ठीक है, या एडिट डिप्लॉयमेंट
ऐसे 2 करके देखते हैं.
ट्रैफिक वर्कर करके रहेगा. करेक्ट? या
यस करेक्ट.
हाँ, तो HTTP API सर्विस करके बोल रहा है ये. ठीक है, HTTP API सर्विस करके बोल रहा है. ठीक है, क्विट करते हैं, गेट सर्विसेज देखते हैं कि क्या हो रहा है. गेट, यार ये मेरे मैक में ना कंट्रोल आर मारा तो फट से स्कैन कर सकते हैं. गेट सर्विसेज,
गेट सर्विस,
API सर्विस तो ठीक है, और
80 पर चल रहा है.
हाँ, तो API सर्विस भी, API सर्विस भी चल रहा है. तो क्या
एक बार एंड पॉइंट से एंड पॉइंट्स राउटिंग ठीक है.
हाँ, गेट सर्विस API सर्विस. सॉरी, अरे यार कॉपी एंड पेस्ट नहीं कर पा रहा. kubectl डिस्क्राइब सर्विस, कौन सा था?
Can you just do the describe the pod and just get the logs once again? Just want to see are they getting continuously? It means disruption in between of some time we are getting response, sometime we are not getting.
Retries getting timed out
Strong.
here. I mean, the entire thing is this only.
I'm thinking, guys, I'm thinking maybe I might be jumping the gun here, but I'm thinking, okay, the traffic worker is getting retry timed out, right?
Yeah.
It's not responsible. It's not the one that is responsible for causing it to retry. Its retries are being timed out. Can we see whoever is receiving this traffic? What exactly is he doing? Can we see the configurations in that service? That the one that's receiving this traffic. That would be either API. I think that would be the API gateway.
Yeah.
Maybe you can describe the API gateway and see the code that is running there, and then maybe we check how the HTTP client in this service is set, because it's failing after a number of successful requests. Can you scroll up? Is this the API gateway?
Yeah.
Okay. Yeah. I think this is the error we saw, something to do with server.
See,
And I can see here.
do not
this one.
modify backend service logic or response characteristics.
We are not modifying it. We are just checking to understand what actually we are running. Maybe to just understand.
No, I don't like. What is the fault you're seeing here? I don't see anything.
Yeah, yeah.
I mean, sorry for this one. Can you please check how many namespace do we have?
I think we are only allowed to this namespace. I think we are in the correct namespace. It's not an issue. Let's see this pod.
Yeah, let's describe that pod and see what it's doing.
Yeah, okay, I'll do that once I check these logs. Okay, retry timed out. We have something now.
Can you
Retry.
check the services SVC?
I already did. Okay, anyway.
Check the port and IP address. Here
It's not-
7681, but here showing.
Try that endpoint. Call using call command once.
Which
maybe DNS is not resolved. That endpoints either via pod inside or.
Let's see if we can get it from here.
I think we can. From pod, you can call once.
Yeah.
On containers.
Correct.
Maybe DNS is not resolving.
Yeah. Let's first, try to find out which service is attached to which service. Okay, lab debug service is attached to lab debug, and API service is to API gateway. Okay, so it is 10.126.117. Okay, get EP. Okay, we have an endpoint. Here, describe SVC API space 117.
API services.
Is 117 endpoint 173. I don't know. 173. 117. Lab debug is 251. Okay, 251.7681. Okay. What else can we check?
Now we check the network policies. Can you check, are you able to connect with the pod? kubectl exe-.
like the thing is, like try to understand the scenario. Like nobody has done anything. Okay, it was working fine previously. Now it is not working. That is the situation. That is the thing that what I've understood. Does anybody differ from that?
Fixing the namespace, timing, blah blah blah.
डिले को 3 सेकंड करना था क्या? I think
the fix must be client worker, not the server. Okay. Okay. अच्छा ठीक है, सर्वर को फिक्स नहीं करना बोल रहा है वो. अच्छा, तो इसको वापस रिट्राई कर लें क्या? ओके ओके. एडिट डिप्लॉयमेंट कौन सा था? अरे यार ये सारा टैब भी नहीं जाता है. कंट्रोल गेट डिप्लॉयमेंट्स ट्रैफिक वर्कर था ना. हाँ,
से एडिट कर लेते
API एडिट डिप्लॉयमेंट ट्रैफिक वर्कर. टाइम आउट जो है इसको 10 सेकेंड्स कर देते हैं. या 10 से ज्यादा करना, पर 10 है तो 15 करते हैं. 15 करते हैं.
हाँ 15 कर देते हैं.
अभी लॉग्स देखते हैं. ठीक है, लॉग्स डिप्लॉयमेंट क्या करना है? ट्रैफिक वर्कर का कॉपी एंड पेस्ट. अरे यार खत्म. अरे यार लास्ट मिनट में निकाल दिया. हाँ, दैट सक्स. ठीक है, मेन कॉल पे चले जाएं.
Yes, yes. Sure.
Okay, so I'm unsharing my screen. Okay. Okay, thank you.
Okay, thank you.
No worries.
You can do just exec into the pod and just execute this.
You
env.
can also use the command set env kubectl. Let me look up that command.
And just increase this timeout to 15. Set set env. Env should be the better. You exec into the pod, exec it and just hyphen bash. Yeah, just instead of yes. Now you can say timeout equals to 15 or something more than that, 20 timeout. Just, or you can copy from above.
This one, right?
Yeah, make it 15. Yeah, equals to 15. Now check env. No, still not. Just time or export timeout equals to 15. If it starts or not, let's see. Check env.
Yeah.
Is it update? Now can you try?
Can you also just confirm? Yeah, confirm again if it's 15.
There's again updated one.
I think you can use the kubectl set env command.
Just set the pod name is wrong or the name is space. Set kubectl. You need to define. Wait. Okay, use this. Okay, use this command. You need to mention what kind of resource this is. deployment or a pod. That's why. So we will put it. I have shared it in the chat. Make sure the names are correct. Huh? Invalid spec something.
Is this a deploy or a pod? Or maybe
No, deployments.
How do I find out if what is strained? Shravan and Rajendra, are you guys here?
Yeah, no idea about. Let's try.
Yeah, no kubectl top.
Let's
see the traffic, right? I mean, from the see the services and try to figure out if any retries are happening because of the DNS failure or something like that.
Okay. I mean, I did not get you. Like, can you tell me like what commands I should run? Like, can you like directly tell me like?
I think you should enter to the log pod and let's check what is running there, and maybe from application logs you can see something.
Do you want me to exec into any pod or anything? And then
Interactive mode, open one.
Which pod do you want me to exec into?
From traffic order, right? Retry timeout.
Yeah, first get the API gateway service URL, right? And try to hit that service from the traffic worker.
So who's sharing the screen?
I mean, time is already up. I don't know if we can do that. Okay.
Anything?
Maybe.
Yeah, let me do a -p.
It is connecting from his traffic to API service. They are connected, right? And then
Okay, it is connecting, and the traffic flow is from what I did was
API
service
traffic.
Yeah, I think it should be from API service to
traffic.
Yeah, so I think I should do the same thing in the API gateway. Let me exec into the API gateway and see if I can reach. I'm just like doing. I have no idea. I'm just doing it. That's all.
Yeah, starting from here. I think we can't access code DNS those or right system names.
I don't have the permission to list the names.
Okay.
So there are only two services: Lab Debug SVC. Other namespaces, I don't know. I can see only two services.
Okay.
I mean, the thing is, I don't have any idea like what these services or what these pods really are. So,
We just have 8 minutes.
yeah.
-v.
Yeah.
Wait, it can.
That service is running on a different port.
Sorry, Rajendra, can you come again?
It's running on different port. That service.
Oh, this is running on a different port. Okay. What that port is?
7681.
7681. Okay. We have something here.
So missing.
Okay, I think the lines are limited in the output. Okay, left. Okay. So the API gateway can reach the labs. This is just a pod, not part of any deployment or anything. These two are deployments, are replica sets. So I don't know what
policy ones.
backend worker, traffic worker. Do we need to create a service right now so that this is reached somehow?
I don't think that's a good idea.
Yeah, because everything was working fine before. Suddenly it's not working.
Maybe
traffic worker, traffic is.
check network policy ones.
Sorry?
Network policy for those services.
I'm not properly, you're not audible clearly.
Okay, check network policy. I'm saying check network
policy. Okay. I don't think that is the issue. No resources. Yeah.
Okay, there isn't any policies.
We just have 6 more minutes. That's the second clue.
What?
No, that's the second clue. I pinged the second hint.
Yeah. No gateway API resource, no HTTP route, no ingress. How is it even being served?
I mean, it's all internal, right? I mean, nothing external, but the pod, the traffic generator is internal, and it's only accessing the other pod through the internal service, API service. So that's why we don't.
The traffic worker is the one that is actually generating the traffic, and it is sending its. I think it is sending its request to API gateway.
That's right.
I think lab debug is the backend.
Oh, could be.
Not exactly sure what lab debug is doing.
Yeah, I mean, I'm unable to understand the architecture, so I'm just guessing. Okay, logs. Address, which is listening on port 7681. Listening on port 7681. Okay, let's exec to this from API gateway 7681. Lab debug, we did not do it. So what is the service associated with the lab debug service? I think we did now, and we got a huge response. I think this is the one that we did.
Yeah, that just looks like a code, like HTML code.
Doesn't look like HTML. Yes. Binary. Yeah. If includes get local name, repeat I. Why are we seeing this? We got that.
Can you check events like in Docker?
Yeah, I can. Successfully pulling image. Nothing here.
No, that's weird.
This is not, I don't know if it is infra related. I am suspecting infra related.
What if we restart? Say.
Why did the timer restart?
No.
Should we just submit and go to the main call?
We are just 2 minutes away, so other one.
Let's try 2 minutes.
Trigger additional word. If we apply that across many clients, what do you get? Are we through 35 minutes or just 30 minutes? Because it said he will increase the timings, right? Increase the time.
Scaling replica set from 0 to 1. I don't know. IPv6. What else can we check? Logs for events, surveys, endpoints, no database. Request timed out. May I just submit and leave?
I think we cannot submit without finishing that, or it will just end. Oh, because you are saying submit because you have the control, maybe. Yeah. Okay, thank you.
Okay, thank you. Okay. Shravan, if I'm not done, please go ahead and. Yeah, I have clicked on submit. I think that's okay.
You can explore out this whole web page, and here we do have you can watch out the trailer here, that how it goes from the very start to the very end. To explain you all the details, like in DevOps or SRE, it is very popular as an 2 a.m. incident or as an 3 a.m. incident, right? So we have explained it out here, what to do, what not to do, those kind of thing. And to show you the things, you can actually join this hackathon solo if you don't have any team. If you have team, if you have a pre-built team of 3 engineers, you can join as a team here. And in a squad of 3, you have to elect your squad leader, you have to elect your incident commander, and then he'll be actually responsible for making the decisions throughout the call. And then you can apply solo, and based on your details, we are going to drop you in a squad. And then there will be a total of 20 teams who will be participating in the hackathon, and that will be the whole flow. That there will be 3 different rounds. Now I'll just explain you the different rounds. So it will happen on 24th of May. We haven't announced it yet. This is the first time that we are announcing it. So it will happen on 24th of May. It will start it from 4 p.m. IST till 12 a.m. IST, and this will be fully remote. And this is the event details of what will be the different keynotes and rounds and all. So the first round, we are going to call it as the first pager, and this is going to be the first round, a battle ops problem statement with 3 hints and AI enabled troubleshooting. Then the second round, we are calling it as an acceleration round, and this is hard the battle ops problem statement with no hints and QB enabled here. And the final round, we are actually calling it as the 3 a.m. incident round, and this will have the elite ops problem statement with no hints and QB enable within. And then these are the 3 rounds as I mentioned, and the timer is also mentioned here, that for 3 a.m. incident, you'll be having close to 45 minutes of time, and then for acceleration you will be having 60 minutes, and for first pager you will be having 45 minutes. And then how we are going to judge you on how exactly you have performed. So time to recover the system into a healthy state, decision quality, RCA quality, and your contribution of the team, the squad, and how many hints that you have used so far. And as you have seen that the RCA is the most important part. So after you complete the lab, there will be an option to create out the RCA. Do not skip it. Just fill out all the details. And then there are some rewards. We are still adding some more rewards on that. So here are some rewards option. And yeah, that's the overall idea about the hackathon. And those kind of folks who are into DevOps, SRE, cloud platform, MLOps, Kate admin, backend, or anyone who is just looking to get into DevOps. So for those, we have created out this. And you can explore all this platform details. I'll just dropping down this link in the chat so you guys can explore it down. Any doubts in it? Like any questions in it?
Any requirements to join? Must someone be a premium member? Or
No.
any-
It's free to join. It's completely free to join.
Okay.
Yeah. Yeah.
So how, is there any prerequisite to join, or
if you'll ask me about the prerequisites, so if you are into DevOps and if you have a good foundation of how exactly observability works, how exactly Kubernetes scalability works in the infrastructure, that's all it is needed. Yeah, Rajendra, as you are mentioning that it is not wired yet. Actually, we haven't announced it yet. So this is the first time that we are announcing it here. So there are yet some fixes that needs to be done. So just for the time sake, I've shown you what we are planning next. Okay, so I believe we have all the folks in the call, right? I can see that few people have already dropped. Okay, so for squad beta, I guess they have joined now. So anyone who wants to share their experience or who have got the idea of what was the issue?
No idea. We could not figure it out.
I would like to share my understanding, what I understood. Actually, there is some mismatch in the timeout and what is defined in the application and what is currently configured in the pod. So in application, it was around 9 seconds day, and in the pod, it was 1. So before application is responding, the pod is getting timeout. So
great catch.
That was my understanding in this time. I was only able to identify this.
Okay. Anyone else who has got any understanding of what was the problem statement? Okay, cool. So just gonna share my screen and then let's start. Yeah, actually the delay was the problem, but to fix that delay, you have to get an idea of how exactly timeouts, the break-ins, the jitters, the delay, how all it works. Okay, and again, if I'll be just let me know if you are able to see my screen so we can get started. Okay, so we have also integrated few environment variables, if you have noticed that. So that was a kind of hint that we have integrated there. Yeah, I'm yet to share my screen, just a second. And we'll not get into details since I've made out a solution video and documentation. You can just go through that. Just quickly giving you an idea of how it actually integrated, how it was introduced towards the infrastructure. So for that, I have created out this documentation, and this kind of problem in infrastructure we call as a retry storm cascade. When something is failing, and that is causing the clients to retry again and again, and just because of slowness of the system, there is a retry storm that has silently killing your whole infrastructure down without any external pressures. That happens a lot in today's infrastructure in different view and different technology tools. But in our case, we do just to make this whole infrastructure a lot simple and focus on the concept, not tools. So for that, we have just created our tools, simple microservices there, a microservice A, which is generating the traffic, and a microservice B, which is handling the traffic and giving back the responses. And then there is a communication breakage in between two. And this actually documentation explains pretty well that how exactly it got introduced in the system, what was the backend change, so and how the backend change actually thought that it cannot break the system. So system, I have also mentioned this point, and this is one of the most important point, that the system was correctly configured on its own. But if you'll see it collectively, and if you will see when everything combines, then it starts breaking on the pressure. I guess there is some someone who has turned their mic. Okay. Guru, if you can actually go on mute. There's some background noise from your side. Yeah, thanks. Okay. So the system was actually correctly configured on its own, but the problem was when it combines with the another component of that infrastructure, then it starts creating the issue on their own. So that was the main concept, and which happens very frequently in organization. Let's suppose the backend team and the front end team or any other team who is working separately, they don't have idea on what kind of dependency other teammates codes can throw on their code, and that can cause a little bit of disruption in your infrastructure. So on that idea, we have created out this problem statement. And how exactly this has got introduced, so if we'll get into this documentation, and we'll check for the backend change of what all changes has been done, the client improvement, how exactly this accelerated into a production outage. So this documentation will explain you how exactly it accelerated into a production outage. But the idea of this lab, of this outage, was to give you an exposure on how to set out the timeouts, how to set out the breakings, how to set out the zitter, the retry policy, all of those in your course, to make sure that it is complementing the other thing, not contrasting the other configuration. And if it is collectively there, then it is going to break your system apart based on the traffic, based on the load. So how exactly it has happened, we have explained all this thing in this, and you can explore this documentation based on your time. And then there is a debugging playbook that exactly says how to troubleshoot this kind of problem statement on your own, what kind of mental framework that you have to prepare in order to understand if this kind of problem statement is happening inside your infrastructure, how to understand this all, and how to fix it on your own. So here are some commands. If you will execute this command, if you try to understand everything that we have explained it, then it is going to make sense for you on how to solve and how to prove, fix, and verify this kind of problem statement, how to create out a mental model on troubleshooting this kind of outages in your infrastructure. So this is a pretty detailed documentation along with the commands, along with, and there is one more documentation that is involved, and that explains similar kind of outages that has happened in the various organizations. I guess if you guys are aware about an organization called Cloudflare, there was an outage happened in 2019. That in that outage, there was a major part of retry storm that has happened because of a collective configuration. So we have exactly tried to replicate that, and we have created out an RCA of explaining that Cloudflare outage, of how it got created in that infrastructure, and how to make sure that if you are handling those kind of infrastructure, then how to fix that. Just allow me 1 second, actually. Just 1 second. I'm just getting constant background noise. I'm sorry. Yeah. So here in this, we have tried to explain, and in that RCA we have a breakdown that Cloudflare incidents into simpler terms, and how they have managed that, and how a simple issue like that can cause a bigger incident in your infrastructure if you are ignoring it for a longer period of time. So just to save on time, so I'll be just uploading down all these documentations, command list, RCA here in this. I'll show you the path. So if you will get into this, you'll be having a section of resources out there. So here we are going to create out a folder of this outage, and then you can explore all these details. It will look like this. I'll show you how it looks like. So it will look like something like this, and if you will click into the details, if you will get there, there will be some documentation. Just click on to just go through, understand on all of those. So you'll be able to see that after the call ends. And this specific lab that we have explored in this call, you'll be able to also access that one. In this lab part, you'll be able to again execute this. Along with, we are going to add out an ELK outage here, an elite ops outage of ELK. So try to explore out that, following up with a core ops outage. So if you are someone who is not that confident in outages, first try to attempt the core ops outage, then the battle ops outage, and then the elite ops outage. And all this will be available to you till the weekend, and you'll be able to access the lab till the weekend, and then it will get expired. So I'll be just uploading out all of these details that I have mentioned, and the main issue problem statement, that was a collective issue. And if you are able to understand how to set all this configuration of backup, of retry, how to set this retry policy, and also we have created out a documentation on that too, how to understand, how to integrate in your application, in production of all those. And if you'll explore that, in the lab we have already created out some environment variables. To fix that, you just need to change out the environment variables while scaling out the deployment. So that was the problem statement, and that was the solution statement. And if you want to deep dive into this, you can explore out the documentation that we are going to explore, and make sure to just give out another try after the session ends on your own. You'll be having the access to explore that. Now let's jump into questions, or anyone who has any suggestions, any questions, and anyone who wants to share anything. Yes,
actually,
yeah.
yes. Hi everyone. So I just jumped from the LinkedIn live. I don't know what is going on. A small brief will help me out.
Okay. So we have actually talked about a problem statement, and then we have tried to debug it down, and now we were talking about the solution of that statement. And you'll be able to explore this problem statement from here, and we'll be exactly providing you the access of that. So that was a summary of what has been explained in the call. And you'll be also receiving the recording of this session after the session ends. Explore.
Okay, so this will be like this, or forge room will be happening on regular basis.
I don't know. So this was a webinar, and this is a different thing. Okay. So this is the hackathon that we are arranging. So you can explore out the details. I'll be just dropping on the link. Yeah.
Okay.
You can explore that.
Okay. Thank you.
Yeah. Anyone who wants to share their experience? Anyone just any kind of feedback or suggestion? Yeah, Guru. You want to say anything?
Yeah. So my suggestion is this is for everyone who was at least part of Alpha or now. It's a culture problem, right? Nothing to do with technology. No one turned on their camera. Yeah. I'll tell you, if you work for a decent company and you're going into an RCA call or a war room, not turning on your camera is considered very rude.
Yeah, right.
Yeah. See, unless you are naked, there's no problem. And if you're naked, just show up to your dadi, no, or your neck. That's fine. Because there are some, of course, I assume most of you are based out of India. I assume so. It's a cultural problem because we don't show our face. The end clients or customers think that we are idiots and they degrade us. That's why you see I'm always on camera, because I have the confidence to face the problem. This is a suggestion for everyone, is that when you go into a meeting or for any call, turn on your cameras. Imagine going into a meeting in your office, yeah, and covering your face. How would you feel? If you are the leader and everyone covers their face, you will be a bit pissed off. Yeah? So
Yes.
it's a suggestion for you. Whether you want to do it or not, it's up to you to decide, but there you go.
Yes. Great. Thanks for adding that, Guru. And I guess I was also in between the travel. I was actually operating from a different area, so that's why it was from my side. Great. I have pasted on the link in the chats, and you guys can follow all those. And anyone who wants to share their feedback, share their experience, suggestion, please go ahead. Stage is all yours.
Hello.
Yeah, Rajendra.
Yeah, experience was good, and I like the concept you made in group discussing the problem. I like that, and in future, if we got the labs like that, it will be good.
Great. Thanks for sharing that. Great. And also that Sanket, if you can show us the video. Are you there? So actually, this is a part of a program that we do on weekends. It is an Infrathrone Elite, and you guys can explore that. Sanket will show you a quick. I don't know if he's in call or what. Yeah. Sanket, if you can show us the video. So let me just explain you out about the video. So that video is about curriculum that we are running as of now, and that we call as an Infrathrone Elite, where exactly we talk about the 4 different pillars of DevOps: the cost engineering, the security, the availability, and scalability. So we usually talk on those 4 main pillars of DevOps, and we handle the production outage based on those 4 pillars. So if you are in an outage scenario, and if you are actually just ignoring the security principles also. Let's suppose if the issue is in the EC2 instance, and if you are opening the EC2 instance to SSH to all, then it can cause a security incident in your organization. So from these 4 different pillars, how to handle an outage, production outage, we usually talk about how to troubleshoot, how to handle the outages with calm nature, and what is the kind of a mental framework that you can prepare in your mind in order to troubleshoot that. And that's the real skill of a DevOps or as a platform engineer that we believe. So here is a video explaining the same. Sangeet, please go ahead and play it out.
Writing YAML, you are already replaceable. AI can do that faster. But when production breaks, systems go down, and alerts fire. AI freezes. And honestly, most engineers freeze too. The industry doesn't need more configuration writers. It needs engineers who can keep systems reliable. The top 1% who can debug and make decisions under pressure. So we built something different. Welcome to Infrathrone Elite. You don't watch DevOps here. You solve it. Build your foundation in CoreOps. Tackle complex multi-system outages in BattleOps. Or face brutal real-world outage patterns in EliteOps. You debug against the clock, with an AI coach challenging you every step of the way. Then, we put you into the war room. You and your squad take roles under simulated chaos. Everything is tracked on the global leaderboard. You even test yourself against AI interviews for real SRE roles, getting detailed feedback on your frameworks. This is not a course. This is production training. Break systems, fix them, and repeat until handling chaos becomes instinct. This is how you move from I know DevOps to I handle production systems. Stop learning more tools. Train for production. Join Infrathrone Elite.
Explore that on your own. And we usually arrange this kind of calls on the weekends, on Saturdays and Sundays. So if you are someone who is interested into DevOps, into platform, you can join us on the calls. And usually on the weekend calls, we talk about the different incidents. Like I guess on Sunday's call, I guess on last Sunday's call, we talk about an incident that has happened with GitHub in April 24th, where exactly GitHub was down globally due to engineers who were pushing down the cloud files in the repos. So that was the biggest incident that has happened in the recent 10 to 15 days. So we have tried to understand that, why it happened, how it happened, try to inject all those and try to understand how to recover from those kind of incidents, talked about AI observability and stuff. So that was some pretty cool stuff that we have explored in the last session. So similarly, I'll be just posting down these also scheduled calls on my socials, and you can go through that if you are interested. And if you are interested in Infrathrone Elite, I'll just also drop down the link in the chat so you guys can explore Infrathrone Elite. If you are someone who is interested into troubleshooting and excelling DevOps with AI, so we actually covered a bit of MLOps there too. So if you are someone who is already having some experience into DevOps, it's not for people who are completely new into DevOps. So for those people who are already into DevOps, at least a minimum of 2-3 years till 15 to 20 or even 30 years of experience will help you understand all these outages patterns and help you troubleshoot that with more confidence. So that is the idea behind this. And apart from that, there are a lot of other things that we are doing in Infrathrone Elite. You can cover all those. And we have also shown you the video to give you an idea of what all is this. And make sure to just attempt out, give it out an attempt of all these labs that we are uploading on this portal, and it will be accessible to you till the end of this week. Make sure to go through that and make sure to create out an RCA on your own and try to use that as a runbook in your future incidents. It will help you a lot. So I guess, yeah, that was it from my side and from Infrathrone side. We have covered a lot, and I hope you guys have learned something out of this call. We have covered a lot of things, and thank you guys for actually staying that much late in the call. I guess the session was supposed to be of 1 hour, and we have covered more than 2.5 hours. So sorry for that if we have extended that. So yeah, that was it from our side, and have a good day, guys. Thanks a lot.
Job is writing YAML, you are already replaceable. AI can do that faster. But when production breaks, systems go down and alerts fire. AI freezes. And honestly, most engineers freeze too. The industry doesn't need more configuration writers. It needs engineers who can keep systems reliable. The top 1% who can debug and make decisions under pressure. So we built something different. Welcome to Infrathrone Elite. You don't watch DevOps here, you solve it. Build your foundation in CoreOps, tackle complex multi-system outages in BattleOps, or face brutal real-world outage patterns in EliteOps. You debug against the clock, with an AI coach challenging you every step of the way. Then, we put you into the war room. You and your squad take roles under simulated chaos. Everything is tracked on the global leaderboard. You even test yourself against AI interviews for real SRE roles, getting detailed feedback on your frameworks. This is not a course. This is production training. Break systems, fix them, and repeat until handling chaos becomes instinct. This is how you move from I know DevOps to I handle production systems. Stop learning more tools. Train for production. Join Infrathrone Elite.